Okay, so for my video demonstration number 1, we're going to be regrouping in base 10 using 10 frames and counters. This is a set model demonstration, and it's for first grade level. So first, we're going to start with the word problem, and it reads, Sarah had 14 cheese balls and Emily had 17. How many cheese balls do they have together? So first, we're going to start off with Sarah's 14 cheese balls. So we're going to lay it out, and we know that there are 10 spots in the 10 frames, so we'll count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. And then we're going to show Emily's 17 cheese balls on the other set of 10 frames. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and 17. Okay, so we have our 14 and our 17 represented, and now we need to regroup. So we're going to take some of Emily's cheese balls and move them to Sarah's 10 frame. So we have 1, 2, 3, 4, 5, 6, and 1 left over. So this shows that we have 10, 20, 30, and 31 cheese balls. Now, if your students have mastered the addition part using 10 frames, I'm going to show an example of subtraction using the 10 frames. All right, now I'm going to demonstrate a subtraction problem using the base 10 frames. First, we are going to read the problem, which says, Adam had 15 crayons and Will asked to borrow 6 of his crayons. How many crayons does Adam have left? So we'll start by putting 15 on the 10 frames for Adam. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we see that this is 10, and I'll go ahead and move these over so you can clearly see that this is 5. So we have 10 and 5, which makes 15. And Will is wanting to borrow 6 of his crayons, so we're going to take away 6 crayons. 1, 2, 3, 4, 5, and 6. So you can see that what we have left is 5 and 4, which equals 9. So Adam has 9 crayons left. For my video demonstration number 2, we're going to be regrouping base 60 using graph paper to represent a linear model. This would be at a 3rd grade level, and we'll get started by reading the question. Stacy woke up from a nap at 1:45 p.m. and has a doctor's appointment at 4 o'clock p.m. How much time does she have until her appointment? So we're going to start off with the number line, and I went ahead and drew out the number line on the graph paper. You always start with the beginning time, which is 1:45 p.m., and make sure you label p.m. onto your graph paper. The next thing you're going to do is label the end time, which is 4 o'clock p.m. So I'm going to label 4 o'clock at the end. Okay, so what you want to do is you want to try and get to the nearest hour. So if 1:45 is closest to 2 o'clock, so that's going to be our first mark, 2 o'clock p.m., which is 15 minutes away from 1:45. After that, we're going to go by hours. So 2 o'clock to 3 o'clock is plus 1 hour, and 3 o'clock to 4 o'clock is plus another hour. So we have represented 15 minutes plus 1 hour plus another hour, which gives us 2 hours and 15 minutes. So that's our answer. There are 2 hours and 15 minutes in between the time Stacy woke up from her nap and her appointment at 4 o'clock. I'm going to demonstrate another word problem, but it's a little bit different from the previous one. So we have the Broadway play starts at 7 p.m. and is 2 hours and 45 minutes long. What time will the play be over? So again, we're using base 60, and I'm using the graph paper to represent the linear model. You're going to start off with the start time, which is 7 o'clock p.m. And again, don't forget to label that it's p.m. And then at the end, we're just going to label end time since we don't know what the end time is right now. So I'm going to label that end time. Okay, so if we know there's 2 hours and 45 minutes in between, I'm going to start by going from 7 o'clock to 8 o'clock p.m., which is 1 hour, and then from 8 to 9 o'clock p.m. is plus another hour. So we still have 45 minutes left to go, so we know that if we're starting at 9 o'clock and we have 45 minutes, we're going to add plus 45 minutes, which would give us an end time of 9:45 p.m. So a common misconception with using base 60 is that kids will get it confused with base 10, and also when you're using the graph paper, they'll count these as 100s. But since this is using time, or using base 60, we are showing that this is represented by 1 hour, and that will help kids figure it out.